Assalamualaikum and hi everybody. I'm Noraza Abdullah. Did you able to answer all the questions I gave you? Please mark your answer as I'm explaining the answer to you and email me at this mail address if you have doubt or need further explanation. Before we go through the answer for the questions, here what I've shown you the syllabus for topic 9. The question that I gave you are within the syllabus. I have asked for the definition of the reaction rate. Determine the reaction rate based on graph of concentration against time. Write the rate expression as differential rate equation and determine the rate decreasing of reactant and formations of product, and also rate expression as rate law or rate equation and determine the order of reaction using initial rate method. For question number 1 is about the determining the reaction rate based on the graph of concentrations against time. So the reaction is about decomposition of AX2 according to the equation shown. The data and the graph were obtained and plotted. So first, define the reaction rate. Then determine the average rate over the entire experiment. Then average rate from 0 to 5 seconds. Average rate from 5 to 10 seconds. And then comment on the difference in value of C and D. For question number 1, A. What's the definition for reaction rate? Reaction rate is the speed of chemical reaction. It can be measured based on the change in concentrations of either reactant or the change in concentrations of product with change in time. For example, let's say if the reactant is A and the product is B, so rate can be written as change in concentration. Change we put as signs triangle like this. Concentrations of A over change of time. So since A is decreasing, so we put sign minus there. Or rate can also be monitored based on the increasing of B. So we put sign positive there for the increasing change of concentrations of B over change of time. So for B, to get the average rate for the entire experiment, rate is the change in concentrations of AX2 over change of time. Since AX2 is decreasing, so we put the sign minus there, since AX2 is the reactant. So change in concentration is the concentration final minus concentration initial. Change of time is the T final minus T initial. So for this experiment, the concentration of AX2 final is 0.0209 and the concentration of AX2 initially is 0.05, and the time taken for the entire experiment is from 0 to 10 seconds. So the T final will be 10 and the T initial is 0. So divide the difference in concentration, change in concentration over the change of time, give you the average rate for the entire experiment. And the answer is 2.91 times 10 power of minus 3 molar per second. C. To get the average rate from 0 to 5 seconds, first draw the line at 5 seconds that touches the curve to get the concentrations at 5 seconds. So from my graph, I got 0.0340 as the concentrations of AX2 at 5 seconds. So the concentration final is 0.0340 and the initial is 0.05 over the time from 0 to 5 seconds. T final is 5, T initial is 0. So the average rate from 0 to 5 seconds is 3.2 times 10 to the power of minus 3 molar per second. D, to get the average rate from 5 to 10 seconds, the final concentration is 0.0209 and at 5 seconds the concentration is 0.0340. So divide by the time final is 10 and the time initial is 5. So the average rate from 5 to 10 seconds is 2.62 times 10 to the power of minus 3 molar per second. So the comment that I can make is that the average rate for 5 to 10 seconds is much less than the average rate from 0 to 5 seconds. So this shows that the rate is decreasing and the reaction slows down. For question number 2 is about the differential rate equation and rate reactant and product relationship. Balance the following equation and express the rate in terms of change in concentration with time for each substance. Nitrogen monoxide NO react with oxygen gas O2 producing dinitrogen trioxide N2O3. If the concentration of NO is decreasing at a rate of 1.60 times 10 to the power of minus 4 molar per second, determine how fast is the concentration of O2 decreasing and concentrations of dinitrogen trioxide N2O3 increasing. For question number 2, the balance equation is 4NO plus O2 producing 2N2O3. To express the rate in terms of the change in concentration with time for each of the substance, we write as rate equals to negative 1 over 4 change in concentration of NO over change of time equals to the negative change in concentration of O2 over change of time equals to the positive 1 over 2 change in concentration of N2O3 over change of time. We write negative sign there because the reactants are decreasing and the positive sign for the product is increasing. Here you can see that the rate for the 1/4 of the rate for the decreasing of NO will equals to the decreasing of O2 and half of the increasing of N2O3. To find the rate for the decreasing of O2 and the increasing of N2O3, first from the given rate for the decreasing of NO, which is 1.6 times 10 to the power of minus 4, we can write it as negative change in concentration of NO over change of time equals to 1.60 times 10 to the power of minus 4 molar per second. Then you know the relationship between the rate for the decreasing of NO with the decreasing of O2 here. So to find how fast oxygen is decreasing, so we relate the two. The rate for the decreasing of oxygen is equals to the 1 over 4 of the decreasing of NO. So we replace the rate for the decreasing of NO is 1.6 times to the power of negative 4 multiplied by 1 over 4. So we got the rate for the decreasing of O2 is 4 times 10 to the power of minus 5. To find the rate for the increasing of N2O3, we find the relationship between the rate for the increasing of N2O3 with the decreasing of NO. So here you can place the two up there so that we can relate the two. We want the rate for the increasing of N2O3. So it will be 2 upon 4 for the rate for the decreasing of NO. So we replace the value for the decreasing of NO, 1.6 times the power of minus 4 multiplied by 2 upon 4. So we got the value for the increasing of N2O3 is 8 times 10 to the power of minus 5. Here you can see that the rate for the decreasing of NO is 4 times than the decreasing of O2 and is twice the increasing of N2O3. For question number 3 is still about the relationship between the rate for the decreasing of reactants and the increasing of product. But here now is given in the form of differential rate equation. But the question is, the differential rate equation for a particular gaseous reaction is given. Write the balance equation for the reaction, and when the concentration of H2O is increasing at a rate of 2.52 times 10 to the power of minus 2 molar per second, find how fast is concentration of O2 decreasing, concentration of ammonia decreasing, and concentration of NO increasing. So from the given differential rate equation, rate equals to negative 1 over 4 d concentration of ammonia over dt, and negative 1 over 5 d concentration of O2 over dt equals to positive 1 over 4 d concentration of NO over dt equals to positive 1 over 6 d concentration of H2O over dt. This means that the stoichiometric coefficient for each of the reactants is given the number below, and when it's negative means it's reactant, and when it's positive means it's a product. So we can write for ammonia, it will be 4 of ammonia react with oxygen, 5 of oxygen becomes the product 4 of NO and 6 of H2O. So when the concentration of H2O increasing is at the rate of 2.52 times 10 to the power of minus 2 molar per second, so we can write in the form of plus a concentration of H2O over dt, d concentration of H2O over dt equals to 2.52 times 10 to the power of minus 2 molar per second. Then for the increasing of O2, we relate the increasing of H2O with the decreasing of O2. So here we can place the 5 on top of 6 here, bring the 5 up here, so we get for the decreasing of O2 will be 5 upon 6 for the increasing of H2O. So for when the increasing of H2O is 2.52 times the power of minus 2 multiplied by 5 over 6, then we get the decreasing of O2 is 2.10 times 10 to the power of minus 2 molar per second. For question number 3 to find the rate for the decreasing of ammonia, we relate the rate for the decreasing of ammonia with the increasing of H2O. For here, we can put 4 upon 6 like this equation. So the rate for the decreasing of ammonia equals to 4 over 6 rate for increasing of H2O. Since we know already the rate for the decreasing of water is 2.52 times 10 to the power minus 2. So we multiply by 4 over 6 to get the rate for the decreasing of ammonia. Then we get 1.68 times 10 to the power minus 2 molar per second for the rate for the decreasing of ammonia. For increasing of nitrogen monoxide, so we relate nitrogen monoxide rate for the increasing nitrogen monoxide with the increasing of H2O. So number 4 here we can place on top of 6, so 4 over 6. So the rate for the increasing of nitrogen monoxide is 4 over 6 times the rate for the increasing of H2O. Since the rate for the increasing of H2O is 2.52 times 10 to the power minus 2, so we can multiply by 4 over 6, then we get the rate 1.6 times 10 to the power minus 2 molar per second for the increasing of nitrogen monoxide. For question number 4 is about rate law and reaction order. Question number 4 says, experiment shows that the reaction below obeys the rate law. Rate equals to K, concentration iodide, concentration bromate, concentration H plus power of 2. A. Define the reaction order. B. What are the reaction order in each reactant and the overall reaction order. C. By what factor does the rate change if 1. Iodide is double, 2. Bromate is half, 3. H plus is double, 4. All reactants concentration are double. So the answer for question number 4, 4A, the definition for reaction order. Reaction order is defined as the power to which the concentration of reactant is raised in the rate law. For B, when the rate law states rate equals to K, concentration of iodide, bromate and H plus power of 2, so means the reaction order with respect to iodide is 1. Reaction order with respect to bromate is 1. Reaction order with respect to H plus is 2. And the overall reaction order is the total orders is 4. For C1, when the concentration of iodide is double, so a rate would increase by a factor of 2, meaning rate also will be double because the order with respect to iodide is 1. For 2, when the concentration of bromate is half, rate will decrease by a factor of 2, or rate will be reduced to half. Because the order with respect to bromate is 1. For 3, when the concentration of H plus is double, rate will increase by a factor of 4 because the rate, the order with respect to H plus is 2, meaning rate will be quadruples. For 4, if all the reactants are double, so rate will increase by a factor of 16. Question number 5 is about determining rate law using initial rate method. Question number 5. Reaction of oxygen and nitrogen monoxide is a key step in the formation of acid rain and in the industrial production of nitric acid. And the equation is oxygen gas react with nitrogen monoxide, 2 of nitrogen monoxide to give 2 of nitrogen dioxide. So the data is given based on 5 experiments. What is collected is initial rate and the initial concentration. A. Write the general rate law. B. Determine the order with respect to oxygen. C. Determine the order with respect to nitrogen monoxide. D. Write the rate law. E. Determine rate constant K. F. Determine initial rate P. And G. Determine X, the initial concentration of oxygen. For question number 5, to get the rate law in general is you observe the equation, chemical equation. You see that the reactant is oxygen and nitrogen monoxide. So rate is proportional to the concentrations of oxygen and nitrogen monoxide, the reactants. So we write as rate equals to K times the concentration of oxygen to power of X, order with respect to oxygen, and concentration of nitrogen monoxide, Y to power of Y, order with respect to NO, nitrogen monoxide. X and Y is the order for each of the reactants which are determined from experiment. It's not the stoichiometric coefficient in the balance equation. Next, to determine the order with respect to oxygen, first we find whereby oxygen is not cancelled but nitrogen monoxide is cancelled. When you look at these two experiments, nitrogen is similar in concentration, so it can be cancelled. So we can divide the initial rate, take the higher value, divide by the smaller initial rate. Okay, that means you divide experiment 2 with experiment 1. So you divide the rate of experiment 2 with rate of experiment 1. You divide the two rate law together of experiment 2 and experiment 1. So here in general first, then only you substitute with the rate, do bigger value on top, smaller value bottom, so that the calculation will be much easier. So 6.40 times 10 to the power of minus 3 is the rate for experiment 2, divided by 3.21 times 10 to the power of minus 3 for the experiment 1, rate for experiment 1. Then you can substitute the concentration of O2, NO of experiment 2 and experiment 1. Okay, so the one with similar concentration will be cancelled. So here you see when 6.4 divide with 3.21 give you 2, and when 2.20 divide with 1.10 give you 2, and it has the power of X. So then 2 power of 1 equals to 2 to the power of X. So X equals to 1. That is the order with respect to oxygen. To find the order with respect to NO, then we find the data of which oxygen will be cancelled. Like here, experiment 3 and experiment 1. The concentration of O2 is the same. Concentration of NO will not be cancelled. So we divide rate for experiment 3 with rate of experiment 1. So we divide two rate law together of experiment 3 and experiment 1. So the one having the similar concentration will be cancelled. K also will be cancelled. So we get 2 to the power of 2 equals to 2 to the power of y. Then y will be equals to 0. So this means that the order with respect to nitrogen monoxide is 2. For question number 5D, so the rate law will be rate equals to K times concentration of oxygen power of 1, concentration of nitrogen monoxide power of 2. To get the rate constant K, so we can choose any of the experiment. Let's say I choose experiment 1. So you substitute the rate and its concentration of experiment 1 into the rate law. Then we can calculate the value of K, rate constant. So the rate constant will be 1726. For question number 5F, from the rate law, rate equals to K, concentration of oxygen times concentration of nitrogen monoxide power of 2. So to get the rate P, so we substitute value of K from previous calculation and the concentration of oxygen and nitrogen monoxide into the rate law. So we got the rate P is 9.63 times 10 to the power of minus 3 molar per second. For G, to get the value of X, the concentration of oxygen, so we substitute all the value of K, concentration of oxygen and nitrogen monoxide into the rate law. So then we get the value of concentration of oxygen level X as 1.10 times 10 to the power of minus 2 molar. So that's the end of the calculation. Thank you.